That's right. Okay, your attention, please.
Hi, everybody. My name is Ivan Morgillo. I'm an engineer. I'm from southern Italy. So most of the talk will be in English and hand moving. Yeah. I'm the author of Rxjava Essentials. It's a step-by-step journey from the beginning of Observer pattern and back to Android and Android development. It has been published last week. You can check it out. My most popular app is Gratis eBooks for Kindle, formerly Kindle Gratis by Amazon. We had a small discussion about trademarks, but still, it's a weekend project. It's very popular in Germany. It's 100,000 downloads right now, and it's a companion app for Kindle users, and it's all about free books. The ebook, no, probably it's $20 something. You can afford it. You're a project manager. Come on. I'll buy as a company, charge them. For the next half hour, mostly we are talking about Android reactive programming with Rxjava, because as Android developers, we have few issues with concurrency, with list events and stuff like that, and Rxjava can be really useful. It's a switch. It's really a paradigm switch, but you can reuse it in a lot of languages because they are basically compatible with everything. If you are iOS, you can use Reactive Cocoa or Ruby or .NET or whatever. You just Rx and your language, that's it. There is Rx Kotlin too for the brave people. Reactive programming is a new idea. It's based on the observer pattern. It's probably 40 years old, so it's quite new. Was made popular by Eric Meyer in Microsoft. Thank you for the truck, guys. He created reactive extensions for .NET, and then Ben Christensen at Netflix ported it to Rxjava. It's an implementation, it's not a port. They were targeting the virtual machine, so you can use it with Scala, Clojure, Groovy, whatever. And it's a huge effort, and it's really a great solution for scalability and complex systems on a Java backend side. On Android, we are using it lightly. It's not that complex, you will see. Rxjava is based on a concept of data flow. Basically, it's like thinking about data as a sequence, and you can imagine it as a river that flows, and you can filter it, merge it, and you can combine it, two rivers. At the end, you will get the river you need. And it's based on the observer pattern, so it's nothing new. We use it every day and enforced the push against the pull concept, because you don't ask and wait for the data. You just politely subscribe and react when the data come in. The observer pattern is basically nothing new. We use it every day. It's the gang of 4 pattern, basically. Common concept. You just observe something that can change over the time, and you just react when the change happens. We don't check our mail every time. We just get a notification. So they push the data to us. It's the same. The spreadsheet is the popular example. We have this total cell, and we update a few values, and the total cell updates. because we expect it, because we are not updating the cell manually every time. We are not checking if everything has changed. We just expect that the value update. And as spreadsheet's main example, we have the concept of everybody can observe changing source and represent the data as he likes. So for instance, we can have a pie chart or a bar chart. We are observing the same amount of data and representing. So it's that the pattern enforces the coupling of stuff. Rxjava implements the observer part, and it's an enhancement, basically, because it adds a few more methods. We have 4 players. The observable, that's the entity that changes or generates new values, new items, and it's let's say the generating, the active part. Then we have observer and subscriber that they are the passive from a subscription point of view because they subscribe to the observable and react when the data changed. And basically we have the fancy one, the subject, that can be at the same time observable and observer. It's useful, for instance, to create edge cases or custom event bus or new version of the observable that you already have. It's really handy, and the moment you get it, you figure out what scenario you can exploit and use it. Basically, the observer and the observable communicate using 3 methods: on next, on error, and on completed. I'm really scared of this animation thing, so I'm checking that. Basically, we have the on next method that is fired when we got a new item from the sequence. The on error, and basically that's the one that is kind of compliant with the Java observer implementation. New ones are on error because stuff can go south, and uncompleted because we want to get a notification when the sequence is over and we are not expecting any more items. So this is the fanciest thing ever. But it gets you the idea that stuff comes from the observable during time, and every time you get a new item, you get it in your on next method and you use it. So, yeah, obviously. We are going to create, this is the example app that we are using to show off a few methods. It's a standard app. It's a bit material-ish. It's using a recycled view and the list of my installed apps. Nothing fancy. First thing first, we create the observable. Can you read it? Say yes, please. It's on purpose. It's verbosely on purpose because I want to show a real example, real-ish. So we create a new standard method and we are returning an observable of the item that we expect. Then we use the create method to create our routine, and in this case, we are fetching the installed apps list, and we create a loop over the list, and the moment we have a new object that we want to emit, we call subscriber.onNext, and the moment that we don't have more items, we just complete the sequence. We are doing it in a for loop. You are not doing it in a for loop, but it's for the sake of the example. It shows how a normal routine can be converted in a Rxjava routine. So you just emit a new item with the on next. you could use on error at some point if you have some try-catch something that can explode. This is the version without retro lambda, so you can appreciate the boilerplate. You can appreciate a few types, something more lines. So now we have created our observable from scratch, but yeah, I already have my apps list. So what if I already have the sequence? Somehow I have a list. And observable.from. We pass a list, and we have an observable. We can subscribe. I don't have a list. I have 3 items, and I want to emit them in a Rx-ish observable sequence. How I do it? I want just emit them, and there is observable.just. So we have our list. We are basically creating for the purpose. We are getting 3 elements, 3 of them, and we are using just to emit them. And we have an Rxjava sequence. What if I want an observable that emits nothing and completes normally? Empty. What if I want an observable that does nothing, emits nothing, and never complete? Never. What if I want an observable that emits nothing and goes on error or throws an exception? You know, conventions. You expect that. Yeah, we were discussing why what the reason, throw, never, it's the testing purpose. I want to test as some timeout goes off some point, and I will need something that doesn't emit and doesn't close. So never could be useful, or throw. Whatever, you can do whatever you want. So we have a few lines of standard Android stuff. We have the recycle view, we have the adapter, we have this fancy swipe refresh layout, or rocket science. And we have our observable from apps, we subscribe, and we provide an observer. Yes. What's an observer? The observer is a bit of boilerplate because we are not fully compliant to retrofit, to retro lambda for this talk. So let the observable, new observer of app info. He has 3 methods, the standard one. Or next, we are getting the app info. We are adding the app info to the adapter, and we are updating the adapter. On completed, we stop the refreshing progress bar, and we show a fancy toast message. On error, something went wrong, and we are stopping the progress bar, and we are showing the toast. So here is the list. Piece of cake. Yes. What's the point? It's just a new thing to learn and is showing a list. But life is funny, so we are here, we have our list, we subscribe, we have the observer, everything's fine, we are happy. Then marketing guys kick in, and we got a change request. We want only the apps that start with C. We want to change as less as possible, so we trust in Rxjava, and we start finding out a few methods that are cool. Filter. Basically, we are using a bit of retro lambda because we like the fancy arrow, and we are filtering. Filter just return a Boolean. It just check condition and propagate to the observer only the items that are fine with the condition. The observer is always the same. He's not aware of anything. He's just waiting for app info objects and display them. So we have a new filter collection with one line of code. So what if we want just 3 elements from the sequence? Guess what? Take 3. We change one line, the subscriber are always the same. Take 3. What if we want last 3 elements? Oh, come on. How? Guess. Try to guess. Try to guess. Huh? You're already skilled. Yeah, it's for the testing scientific thing. It's no WUPIA tester. It's research. Take class. There's a bunch of filtering methods. You could use skip 3 because you know that your first element of the sequence is some kind of check element. It can happen. You will ignore it, and you just say skip 1 or skip last. If you know that your sequence complete with a check value or something, you skip it. So I hate duplicates. How can we be sure that we are processing one element once? It's one time. The observer it doesn't know anything. It just reacts. So we don't know where the data are generated, when the data are emitted, when the sequence will complete. We want something that filter out the duplicates. For the example, we don't have duplicates in our app list, so we are creating it. We are creating a fake, full of duplicate sequence with Rxjava, because why not? We take 3, we repeat 3. Now we have a 9-element sequence full of duplicates. At this point, we can search a method that will get rid of the duplicates. Distinct. Piece of cake. The observer is still the same. It is the poor guy. And this scenario is the poor guy. He knows everything. Basically, it's Italian. He knows nothing. It's just shut up and display the thing. I'm being racist, but I'm Italian now, so I'm loud. This thing will work on a completed sequence because, it's from a logical point of view, if I have to get rid of duplicates. But a new scenario comes in. Ongoing sequence. I have this temperature sensor in this room that is emitting the current temperature of this room, so I'm getting probably 25 here or more. It's hot. For our American audience, it's 77. It's hot. Not hot like me, but hot. So it's time depending. Every second we are getting a new value, and we are displaying the value on a small display. But we are going cheap, so we are kind of trying to save resources because everything is expensive, and we don't want to over refresh the display with 25, 25, 25, 25. We need something that will filter out the duplicates, but how? It's an ongoing sequence. This thing until changed. It will listen, mirror the observable, and give you only the new value. So you will just wait for the new value, and the moment it goes to 24 or 26, we fire on next, he fires on next. I don't know anything. And we can subscribe, and we can update the display less often, just less often. We are saving resources. Loosen it up a bit. Yeah, we are getting the one value every second. Do you think the temperature will change so quickly? No. So we can, change somehow the emission rate. Guess. Sample. Sample creates a time window. You can specify the amount and the time unit, and it will emit the last item from the original subject, from the original observer in the time window. So you are getting only one item every 30 seconds. Then we could concatenate distinct until changed, and we will get probably, one element every 10 minutes because it's not changing, but we are not stressing with every second. Sample take the last, throttle first take the first because, there is everything in Rxjava. If you need the first element of the window, you use throttle first. Now what? Transforming. We have our fancy list. It's piece of cake. It took 5 lines of code, and now we have the marketing guys. So they decided that from a marketing point of view, the list has to be changed somehow in lowercase names list. So we don't want to change so much code. We want to apply a function to every element emitted from the original observer. We want to map the item. A cool concept. So basically, we take the element that is emitted from the observable, we chew it somehow, and we return the item to the observable sequence. It's 1 line of code, and we got the new lowercase. Map is cool because it's taking app info object, but it could return everything. So most of the time we are working what we have on Android mobile because probably the backend is already there, so we are not in charge of changing stuff. What if we just want the list of names? We could use map to extract the name, and instead of return app info object, we could return the string. The observer, of course, will change. We will be observing a string sequence, but still, we were using, our original object is a apps list. What if we want the bitmap, just the bitmap? We want to observe a bitmap sequence. We take the same list, we extract the bitmap from the object, and we return the bitmap. And now we have an observer that can, change and use just the bitmap list. Rxjava has a bunch of transforming functions. Flat map is the famous one. It's kind of tricky to get it because it's like map, but it's returning an observable. Basically, if we start using Rxjava, we get at some point that we have a few methods that are small routine because they are testable and they are returning an observable. So how we chain an observable in an observable sequence? We use flat map. So basically, when we are attaching flat map to an observable that we have, we are passing the object. It will work on the object, process the object, and return an observable of some kind. We are chaining observable. That it's unbelievable for async task word because we can chain async task or stuff like that. But flat map has is edge case, and for instance, it interleave the result because every observable could run on a different thread. So Rxjava just gives you concat map. That solved the issue because there is a method for that. There is an app for that back in time, and there is a method for that now. Transforming easy one, cast. Cast, we have to, for somehow, cast every item we get from a list to a new type. Cast and the type. For some reason, we need to observe a subset of item in form of a list. We use buffer. Buffer mirrors the original observer and gives you back list of this example 3 app info, for instance. If we apply it to the previous example, so basically the sky is the limit. Combining example, we have our app list as an observable list, and then we create a reversed version. How can we merge 2 observable that basically are emitting the same kind of item, app info? We don't want to change the observer because it's the poor guy. So what? We are merging 2 observable. Oh my God. Merge. You know, it's like COBOL. Just use English. We are creating a new observable, merging 2 observable. Our observer is not changing, and now we have one single emitting sequence. Fancy one. We are introducing a new operators, interval. We have 2 different observables. It's our list. And the second one, TikTok, it's emitting along every second. It's just a dynamic observable. It's for the purpose. Now we have a fancy update title routine. Takes the number and create a new string with a number at the name. And return an app info object. How we combine everything together. We use zip. Zip takes up to 9 observable and mirror them and pass the last unzipped emitted item to the function. So basically, this is the fancy Java 8 something syntax. It comes with retro lambda. Basically, we have 2 observable, a function that takes 2 elements and return app info object. The observer is always the same. Now, Android. It's a bit ugly, but serves the purpose. Our list fetches stuff from shared preferences. It could be interesting. Yes, it's Rxjava. Yes, works. Yeah, could be obviously better because we are instantiating JSON every time. So it's there just for the example. Everything is fine. We are using Rxjava. We feel very, 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 very comfortable with it. And then we enable strict mode. Strict mode just throw out disk read violation. Basically, we are doing stuff on the main thread. We are reading from the disk on the main thread. And we are losing 253 milliseconds to read the list. So that's the main problem. UI thread is the main thread is the UI thread. If you do stuff on the main thread, you slow down the UI. Animations start to suck, stuff like that. So we need some way to do the work away from the main thread. We could use async task. Please leave the room. We are using Rxjava because there is a method for that. We have schedulers. We don't do multi-threading manually. Come on, loaders, async tasks, threads. No, it's not 1995. So we have schedulers. Rxjava gives you schedulers. This case, schedulers.io. It's based on a pull thread. So Netflix handled the thing. I don't care. I have a daily job, you know. I don't. And basically, the thread pool increase the size, decrease the size. Every time we need to do something that is I/O related, reading from network, from a database, or from the disk, or whatever, we can use a scheduler.io. We subscribe on the scheduler, so we ask to Rxjava to do the routine, the stuff in get apps list on a different thread that is supposed to be the I/O thread, or scheduler, I mean. We are happy, we run the app, and the app crashes. Obviously, only the original thread that created a view hierarchy can touch its view, because it's Android. Android, back again to Android. We are doing stuff on a different thread, and we are trying to update the recycled view from a thread that is not the UI thread. So, you know, it's kind of getting tricky because we have to do the job on one thread, somehow come back with the result on another thread that is the UI thread. Oh my God, probably the async task is the answer. And no, because we have observe on, because there is a method for that. So thanks to RxAndroid, we have a scheduler specific for Android that let us get the result on the main thread. So basically, in 4 lines, we are fetching the stuff from the disk using a different thread. But when the data come in, we want it on the main thread, because we are updating the UI. That's it. Piece of cake. Read from here using this thread, and when you have the data, I'm here on the main thread and waiting politely. This is the pointless one, but it serves the point. We are generating a new observable that, before emitting something, just does a few nonsense math things, just waste time. We are on the main thread, so we got the fancy dialogue. And if we are lucky, we got the dialogue. If we are lucky, the system is complaining about we are skipping frames, how there was no tomorrow, because we are blocking the main thread. But it's not a UI thing. So scheduler UI I/O won't serve the purpose. So yeah, we have other schedulers. So if you have to do computational things, we have computation scheduler. If you want to execute something now, we have immediate scheduler, or we have new thread scheduler, because you just want a new thread. So schedulers.computation, schedulers.newthread, schedulers.trampoline, if you want something queued on the current thread, could be useful. There is a method for everything. So, real-world app. We are using a retro lambda. I like the arrow. I don't care about the mess it does with a bytecode. I like less boilerplate. I'm using retro lambda in huge application in production for huge sports events. It's working. I don't care about how they do stuff. I have a daily job. I need to be on the spot. I don't care about stuff. I'm using butter knife because I hate that find view by ID. I can't stand it. I'm using Lombok. I don't care how it does stuff because I'm too old to create manually getters and setters. Come on, I'm too old. I'm using retrofit because it's the only way we can properly communicate with the REST API. Thank you guys at Square, and let's hope Google never buy you. I'm using universal image loader because works serves the purpose. You can use Picasso, you can use Fresco. It's just an image loading application. And this is the application. It's a kind of easy thing, list view or cycle view or whatever. We are fetching data from Stack Overflow. We are displaying the picture, name, reputation, number, city, and we are fetching the forecast from Open Weather Map API. We are attaching a listener if the user tap one of the items. If the Stack Overflow user has a web page, it opens the profile, or it opens the Stack Overflow profile. So we have Retrofit. Retrofit has a brilliant implementation. They just map the REST API to a Java interface. Basically that's it. They support Rxjava out of the box because they are smart people. I mean, why not? So we are mapping the response to a Java object. I'm too old for creating the objects manually, so we are using JSON schema to Pojo because, I have not so much time, and that's it. So we go to our API manager for Stack Exchange. We create the minimum thing for Retrofit. REST adapter, we bind the service, the interface we had, and then we provide get most popular SO users method, like names, there. The first thing of documentation is method names. Basically, we are wrapping the API because we want to kind of shield it, and most of all because we are getting a response that it's not perfectly fitting our needs. We are using a list of users. And basically, we are getting the stuff. We are mapping the observable, so we are extracting the user list. We are working on a scheduler I/O, and we are getting back the result on the main thread. Piece of cake. It's an activity. It's standard. I get rid of all the boilerplate. I just want to point out that it's a normal recycle view, adapter, and swipe. And we have the refresh list method. Basically, we are getting the API manager somehow, use Dagger too. We are getting the users. We stop the progress bar. We update the adapter. Or if something goes wrong, we just print a message and we stop the progress bar. Ta-da! Now, the weather thing. Same as the Stack Exchange thing, we create a manager because, stuff it's more organized. Don't create a single like that. Use Dagger. It's just for the purpose of the presentation. We have the get forecast by city method that basically wrap the API, use a scheduler I/O because it's a network call, and we get the stuff on the main thread. So we update our adapter for every user we put in the list. We query the forecast service. We filter for null. Could happen. Actually, it happened. We filter again. We don't need the weather if the size is not. No, it has to be greater than 1. We could use one line, but it's, and then we concat a new observable because we are reactive, so we are fetching the forecast, the bitmap, using an observable method that takes a string and gives back a bitmap. We want to chain everything together, so we flat map. We make sure that we are working on the scheduler I/O. We get the stuff on the UI thread because we are changing the view. We get the icon, we set the icon. Something goes wrong, we log it. And we have it. RxAndroid perks. We can attach a listener to a view with viewObservable.clicks. It's useful. The moment we have the profile, we open the profile. The moment we have the viewer, nothing. Yes. We open the Stack Exchange thing. So basically, it was a short presentation, sorry. We have an amount of methods that it's unbelievable. There is a method for everything. So I could talk probably for 2 days. You will kill me at the end. But the thing is that Rxjava gives you the opportunity to create your own operator. So it really could be endless. There is an operator for everything. The mind switch is you have to think the observable sequence like water, like rivers. You can filter a river, you can transform a river, you can combine 2 rivers into one, and it will still flow. In the end, it will be the river you want it to be. Be water. Thank you, everybody.
Thank you.